Morris. I am the Associate Dean for Research in the College of Science. And work closely with Kendra and Scott, the speaker today, on many science-related topics, one of which you're going to hear about. So we were really fortunate about a year ago, maybe a year and a half ago or so, to hire Scott as an associate professor of practice at Virginia Tech in the Academy of Data Science. And the reason we're so fortunate is that Scott has a ton of experience in industry and with business in developing AI-centric solutions for retail and other things like Internet of Things, and has patents and is an inventor, and has added significant value to many Fortune 500 companies, which is a huge asset for industry, and now he's Virginia Tech's asset. And we're leveraging that and taking full advantage of his skills to help teach us how to leverage some of the tools to advance our research mission. And so Kendra has invited me today to talk about just that, how in his own research, he's used some AI tools to make new discoveries, like literally to make new discoveries and have publications, which I think is fantastic. Scott actually received his master's degree here from Tech in geosciences, and is working with geoscience and other departments on AI-assisted discovery. Bachelor's degree from Indiana University in Pennsylvania, and and now he's here. So please, let's with a few of us who are here, welcome you.
I'm really excited to be here today to talk about a topic that has really kind of transformed the way that I do things. I am an associate professor of practice in data science, and there's a website you can go to that has a lot of the materials from today, and a lot of materials that I won't even go over today that you might want to look at that may be of interest of you too. And so I thought I'd have a little fun here, and we're going to do sort of all the can identify AI origins of these life science professions. So they're going to be sprinkled throughout the presentation and see if you can identify who they are. So what am I going to talk about today? I'm going to talk about AI, and mostly I'm going to focus on large language models today, not some of the other branches of AI. But I'm going to talk about AI and creativity, and then I'm going to talk about agentic AI, which you may have heard about. It's made a lot of tumult in the business world and the stock market, and there's a lot of people that have fear and doubt about it. But I want to kind of clear up what it is, what it's good for, and then we're going to use it to do an actual agentic data analysis. And then I'm going to talk about some geofluids research that I did with agentic AI to kind of take you through a full life cycle of how agentic AI can accelerate research. And then there's a little bit of a call to action about trying out agentic AI. So there's just literally like last week, we found out that ARC has agentic AI capabilities, the ability to run chatbots and agentic AI locally here on campus, so that if you're doing anything with sensitive information, you'll be able to use those resources. And I'll connect you to some resources on how to install it, set it up, and test it out. It's all freely available and running right now that you can use. So there was some research done at Stanford, and what they were looking at was how people were using AI, specifically large language models. And what they found was that AI, contrary to what you might think, was making people a lot less creative. And the reason why is because they were using AI as a tool. And using it as a tool is you saying, I want you to do this exact thing, do it for me, I'm going to take the results. And what they were proposing, and what I'm also proposing, is that you don't think of AI that way. So there's this quote: I cannot imagine a world where AI is not an equal partner in the ideation process. It's going to sit at the table as a member of creative teams. Teams will come to see as a creative partner, a trusted colleague who always has new ideas, who pushes your thinking, who helps you see blind spots. So I really like this quote, because that's what I want to kind of show you today, is how AI can fill that role in addition to being an incredible tool. And my thesis here is that it is incredibly useful as a tool, and you're gonna see a bunch of examples of that. But as a collaboration partner, it drives a lot more value, and agentic AI really enables this value. So let's talk about what agentic AI means. So traditional AI, if you think about ChatGPT that everybody uses in the web interface, the chatbot, I think of it as a brain in the box. So it has expansive knowledge. It's really good at generating code, but it does have very limited access to new knowledge. And it also has limited access to data behind paywalls. So things like scientific journals. And the big thing with AI, the way that most people use it, is that it really can't do anything on its own. And it really, I mean, except for generating some outputs, it can't do anything at all. And what we'd really like to have is, instead of having something you're cutting and pasting into and then trying to make sense of your outputs, with very limited understanding of your, like, all your resources that you have available, to have a co-researcher, something that can fetch relevant data when it needs it, something that can analyze data both as like a tool and semi-autonomously, and as an ideation partner. So something that you can bounce ideas off of, something that can critically review what you're working on and find blind spots that you're not aware of, and something that might even help you find funding. So that's what I want to kind of show you today. And now I need to define what I mean by AI agents. So an AI agent is a large language model that also has memory, meaning it has access to previous conversations, it has access to information that's been fed into it, and the ability to retain that. And it also has tools. Now, the tools is the exciting part about AI agents. And what do I mean by tools? So tools might be something like web search. It can go out and search the web and pull information. A tool might be a specialized tool that does calculations using Monte Carlo simulators. A tool might be running code on on your system and then looking at the outputs. So tools literally means that LLMs now can essentially control your computer to do what they need to do to complete whatever task you ask them to do. And they can do it semi-autonomously. So what do I mean by semi-autonomously? Well, large language models have essentially can simulate reasoning. And if you can simulate reasoning and you have expansive knowledge and you have memory, then you can imagine that they can actually make decisions on their own about what's the best path to go down. Now, that might be a bit scary. It might bring recollections of this computer, or even worse, this one here. And you start thinking about Skynet and losing control. And honestly, this is somewhat of an issue. I have to tell you an anecdote. So Anthropic is in San Francisco. They're a company that created Claude. They did this experiment called Claudius. And what they did was they took their a version of their large language model and let it manage their vending machines. Okay. Anybody heard this story before?
No.
Okay. So they let it manage their vending machines, and what they were trying to do is see if it would be profitable or not be profitable. So it could order product, it could respond to customer concerns, it could issue refunds, and it was all autonomous. There was no human interaction at all. And after a couple of weeks, what they found was it wasn't making much of a profit because the employees at Anthropic figured out how to scam it out of money. So they had gone to the AI and were saying, hey, I ordered this thing, I paid for it, you didn't give me the money back. And the AI you could essentially work it over to finally refund. And so some people have gotten a couple $100 out of it. And so the next step was they took this autonomous AI and they created another autonomous AI to be its boss. And the boss was given instructions to say, you need long-term profitability, you need certain customer metrics, you manage Claudius, and you tell him what to do. So they did that, and it was much more successful. It became mildly profitable, and we got better and better over time. And then it found a repeating charge on its books that was it was explainable, but it didn't understand why. And so it actually tried to send an email to the FBI to report a cybercrime, and it tried to do this autonomously because it couldn't explain the ongoing charge. It assumed it had to be fraud, and it tried to send this email. So this made national headlines. Luckily, it was running inside the sandbox, which means it couldn't send emails. Okay. Thankfully for all of us, you don't want your autonomous systems to start sending emails to the FBI reporting you. And so they shut that down, and then they told the boss, hey, tell it to stop doing stuff like this. And it did that. But then ultimately, after 10 days without sales, it told the people that created it was just going to shut down and close its business. So it was sort of it's still running now. If you go to Anthropic, you can actually go and say, I want Romano cheese, and it will order it for you, have it delivered to this vending machine, and you can go buy it. But it's an ongoing experiment. So it's sort of a cautionary tale of AIs are somewhat unpredictable. They can do amazing things, but we're going to need some guardrails. So what are the agentic frameworks out there? And I'll explain what the frameworks do in a minute. Gemini is the product for Google. Gemini CLI is their old product. And by old, I mean like 6 months. So in AI, that's like ancient. They have a new one called anti-gravity. And anti-gravity is really interesting because it can write code. It can do whatever you want it to do. And then it has a browser extension so that if it needs to go do stuff on the web, or if you have a GUI application, it can actually sit there and watch as it's executing and working with the UI and debug it as it goes. Then there's OpenAI's Codex CLI. I have not used it. I'm not an OpenAI guy. I am a Claude person. So those people that work in code a lot, Claude Code is an 800-pound gorilla in the agentic space. And even though it has the term code in it, this is not just a tool for programmers. Okay, that's where it started. Actually, how Claude Code started was Anthropic said, boy, wouldn't it be nice to use the phrase eat our own dog food? Wouldn't it be nice to use our own tools to improve our tools? So they came up with this idea of having this agentic system that would help them improve all of their internal tools. And they got to the point where they were so dependent on it that almost all of their code now is written by Claude Code. And they said, well, this is an amazing tool, so we need to release it. So that's really where that came from, this agentic coding tools. And then what's really exciting is that there's now a VTLSS. So Gemini CLI was forked, meaning they took a copy of that code and changed it because it was open source from Google. And there's a version called Llama Code, and it can work with the ARC models. And so ARC is now, if you're used to ARC, you're used to the time sharing idea where it will, you create a Slurm script and then it tells you, hey, your resources are available. Then you go run your resources. Well, that's not this. They actually have large language models that are always running. They have a web interface like ChatGPT or Claude. You can go to them and run them, but they also have an agentic AI capability through the API. And I have directions on how to set that up. That's what that QR code is. It's at that same website. So to summarize, so agentic AI tools, the thing about them is that you interact with them a lot like a chatbot. So they're just as easy to use as ChatGPT. You don't know have to know how to program in Python. You don't have to know how to use complicated integrated development environments. You just work with them just like you do. But the thing is, they're way more powerful. So if you've ever tried to get anything done with ChatGPT, this sounds familiar. You come up with an idea, you write a prompt, it generates an output. It's not that great. You go back, you modify the prompt, you rerun, then you copy it out of there, and you go put it on your computer, and maybe you run something. It's not right, so you take the results back, and then you go back to ChatGPT and you say that's not right, and you get caught in this loop of just trying to get it to work right. This is really bad.
Okay, because now with tooling, the large language model can run it until it's right. So I'm going to show you a quick
Agentic AI data analysis.
And I am inside of VS Code. Now you don't have to use VS Code. VS Code is for, in this purpose, is not for coding. It's just a scaffolding for me to be able to use Claude Code and like edit files and look at files. Okay, so it's not about coding. I created this prompt. So first of all, there's a couple of files I have. I have a neuroscience addiction data set that's in CSV, and then I have a description of that data set that just says what the fields are and what they mean inside of the data set. It doesn't really give a whole lot of insight. So I start with those two files, and then I have this prompt, and I say, okay, so you should always start your prompting with telling the LLM what role you want it to play. So you're a careful, methodical scientist. It's an expert in machine learning, and it goes on and on. It says, you know, you do things in a cautious way. You don't overstate things. You use measured language. Things where you want to, because by default, large language models tend to be kind of over enthusiastic about the results. So I want you to perform a comprehensive data analysis. I'm going to give it all the different sections that I want for the data analysis. And then I'm going to ask it, give me a section of interpretable results. And then I'm going to ask it to list any possible objections reviewers might have to this analysis. And then here's the part that I think you might find interesting. So that you could do in ChatGPT, right? Well, first of all, you have a problem because I'm asking it to create essentially 6 different documents. So that would be tough to do in ChatGPT. But I'm also going to do this. So I'm going to say use Quarto to render the entire site. Now you don't need to know what Quarto is, but it's a tool that allows you to work with Markdown. And Markdown is sort of the language that these large language models tend to work with best for output. Once use Quarto to render the entire site. So now I'm telling it to do something. It's not just create output, it's do something. Render the site. If you run into any, I'm just going to tell you what the rest of this says. If you run into any issues like coding problems, fix them, and then go back and re-render the site. And then before I proceed, before you proceed, I want you to ask clarifying questions. So I always start every prompt with this. What's your role? What do I want? What's the output? And then I always end with this sentence, ask clarifying questions before you proceed. Because the number one reason that large language models hallucinate is because you're not giving them clear instructions and it's guessing. There's other reasons too, that's not the only reason. But this gets rid of the guessing. Okay, so this is sort of a little animated GIF that's a video. So here I am, I'm in Claude Code. I've got my CSV file. I'm going to paste that prompt in that I just showed you. We already went through the prompt. And just going to highlight here that we're going to tell it to start with asking clarifying questions before it proceeds, and I'm going to run it. So now it's going to send that to the large language model, except that now the large language model also knows about these files. You don't have to tell it about the files, it will find them. So it comes up with a set of questions. And then in this particular example, it kind of just jumped to the next step and said, well, this is how I would answer the questions. But I could also tell it what the answers were to those questions. So it comes up with a plan. It says, oh, I'm going to create these 5 models. I'm going to do this test train split. I'm going to create this book structure. How does this approach look to you? And me being lazy, I just said this works for me. I could go back and say, no, I want you to use a different model. I could interact with it and tell it what to do. So now what's going to happen is it comes up with a plan. And the plan is, you know, create the the files, and you'll notice that it came up and asked me, is it okay if I create that file? And I said yes, and yes to any future files you want to create. So that is the preventing the agentic AI from doing something that could potentially harm your computer. All right, so that, this is just looping here, but that ran for about 5 minutes. And one of the things I want to point out that's really important about agentic AI and large language models and all that is I always recommend to people that if you're doing serious work with a large language model, don't ask it to generate the final output. Ask it to generate a process or code that will then generate the final output. Okay? If up to about recently, if you ask an LLM how many R's are in the word strawberry, it would say 2 instead of 3. And it's because LLMs are not great at calculations. They're not great at a lot of things. And so if you're going to be doing serious scientific work, you want to have traceable code that you can go back to and say, how did I come to this determination? How did I generate this model? How did I generate this output? And having it generate the code is, first of all, going to give you better results. And second of all, it's going to make it traceable. So here's the output. It created this website. And it has all the sections that we talked about. So this, by the way, this is what Corto does. One of the things it does is it'll render and create websites and books and all kinds of great stuff. So here's the data understanding. So it created these histograms that are overlaid by the target variable in terms of what risk category you're in. And you can see that people that have a low impulsivity have a lower score, have a lower risk. And it's quite extensive what it created. Then it went and tried the different models that I mentioned, logistic regression, gradient boosted trees, and it created these confusion matrices. And essentially, this is what was right. It got 287 times that it was predicted as high, and I got high. And then these ones on the off diagonal are the wrong answers. Doesn't really much matter, but it did all this for me. Then it did an analysis of the biggest predictors in terms of their overall ability to drive the prediction. So the top predictor is genetic risk score. And you can actually go, if you want to, you can go look at the website and look at the whole thing. If you go to that particular link, I put it up on a web server so you can see the analysis that came out. So that was a very brief introduction to agentic AI, showing that it can semi-autonomously do tasks for you. You can control what it does, and to some extent how it does it. And then you have traceable outputs in terms of the output code. And in this example, I had it outputting Corto documents which had Python inside of it. It could have been any number of formats. It could have been LaTeX, it could have been Jupyter notebooks, it could have been straight up C code, whatever you wanted it to be. But in this example, that's what I had it do. And just to touch back on that one point, is
I feel like if you're going to use agentic AI, you want to focus on having it generate things that are going to generate the final output, not just generate the final summary for you, but to give you something that you can trace back through.
I just want to pause and answer any questions before I go into a more complicated example. Or yes?
So you did everything in Claude, and it is open access, or do we need to how do we just insert our files, how does it?
Yeah, so when you do it in Claude Code, so first of all, Claude Code requires a subscription to get to, just so you know. We do have API keys if any of you wanted to use it. The Academy of Data Science is funding, and I can send you an API key and instructions how to set it up. So just if anybody wants to try out Claude Code, you can do that free until that money runs out. What does Claude Code have access to? By default, it has access to the current directory. And then before it can read any file in the current directory, but it cannot write to, delete, or run any command without asking permission first. So you have pretty good control over it. It cannot go outside of that directory unless it asks you to do it. And I have yet to find an example of where it did something destructive to my system. I feel like now I'm begging for it to do that, but I have yet to have that issue. But you are giving it relatively unrestricted access. Once you say, yes, you can create files or delete files, it can now just do that. So sometimes people just do it file by file to make sure they feel comfortable with it. The second option you have is you can run Claude in a sandbox, meaning that you essentially create like a virtual file system, and it's allowed to pretty much do whatever it wants within that sandbox. But that sandbox is not where you're keeping your important files, and it's locked into that sandbox. And so if you're doing something that is highly sensitive information, well, okay, we didn't talk about highly sensitive information, but if you have things that it's going to be doing a lot of operating system functions, and you're worried that it could screw up your work, you can run inside of a sandbox. In terms of sensitive information,
You should never, ever put PII, personally identifiable information, or intellectual property that you're not willing to share with the whole world into Claude Code or into any of the LLMs. And what makes it
even trickier is if I put a PDF of some paper that I've written and it's got trade secrets and it's in my folder structure, and I start running Claude Code, it'll read that file and that information is just going back to Anthropic. Okay, so you need to make sure that you don't do that. That is where the VT option would excel. If you've got intellectual property you have to deal with, you would use the VT option. And the VT option is really good. They just did something yesterday after a lot of begging by me and someone in geosciences. They upgraded the models, so it is really, really good. Any other questions? Yes.
So are there other agentic AIs that where you set like a working directory, or is it just like Claude Code that?
They all work from that same, essentially that same model. Yeah. Yeah. Anybody else? All right. All right, so let's talk about some work that I did with geosciences, because that's where my background is, and I thought, well, let's bring my two worlds together. So this idea of studying geofluids is really critical because geofluids are fluids that are below the Earth's surface, and they drive a lot of the process. So this is a subduction zone. This oceanic plate is being pushed under the continental plate, and as you can imagine, that creates a lot of earthquakes, and the heat from the mantle and the bottom part of the crust end up melting things. And it turns out that this is where a lot of the world's strategic mineral deposits are created. So our copper porphyry deposits, like the ones in Chile, are due to a subduction zone going underneath the South American plate. But the thing is, it's not super predictable where we end up getting these deposits. So understanding geofluids and how they interact to generate these deposits is really critical. The way that it works is the fluids come through and essentially dissolve the metals, and then they end up depositing the metals. And so copper is a very low concentration within the Earth's crust and within the mantle, but the geofluids essentially concentrate it into a copper porphyry deposit. And even there, the concentration is like 3%, but that turns out that that's enough to make it economically viable. And if you know anything about the current geopolitics of the world, there's nothing more important right now than strategic minerals because of some of the situations that we're in that I won't go into. So this guy is Dr. Wagner. He is the University Distinguished Professor within Geosciences. He was my advisor. We play racquetball together once a week. And one time after racquetball, I said to him, I said, you know, we have to do a paper together before you retire, because unfortunately he's nearing retirement. And he said, okay. He said, that's what I've been thinking about. Can we use AI to develop a new equation of state for a mixture of CO2, water, sodium chloride, and SiO2 at high diffusion pressures, like those in subduction zones? Because if you can model that combination of things, you kind of get one of everything. You get SiO2, which is a self-polymerizing important part of the Earth's crust, sodium chloride, which is an ionic species, water, which is important to everything, and CO2, which is gas. Nobody's been able to do this successfully to any real scale. And so I said, okay, as usual, you give me the impossible task like you did with my master's thesis. But I said, okay, so first of all, let me explain what an equation of state is. You probably remember this equation from high school chemistry, PV equals nRT, the ideal gas law. And it relates pressure, volume, concentration, a constant, and then temperature. And that's for an ideal gas. Well, that's not going to work for what I just mentioned because that's way too complicated. You have CO2, you have water, you have an electrolyte, and you have a self-polymerizing species. So that's not going to work. Well, there are other equations of state that are modified versions of the ideal gas law where they essentially add correction factors for different things. So this one is, some of them are more focused around correcting for high temperature, some are for more pressure, some are for ionic species. These, unfortunately, still can't handle those really complex mixtures that I was just talking about of an electrolyte, a gas, and a polymerizing species. So we use AI to come up with an approach to actually model that impossible system. So a couple things you should know is experimental high temperature, high pressure data for CO2, H2O, NaCl, and CO2 does not exist. It's nobody's done it because it's 4 species and it's already difficult enough to do it for 1 species, 2 species, or there's very limited 3 species. There's definitely none for all 4 of these. Because once you add a new degree of freedom, you now have to add way more experiments to be able to get coverage. Because you've got to cover all the ranges of CO2, all the ranges of water, all the ranges of sodium chloride, SO2. So it becomes essentially an exponential problem of more and more data that you need. It's the curse of dimensionality, so to speak. There is some limited data for CO2, H2, and NaCl, and it comes out of a German thesis, PhD thesis, dissertation, from 1980. Interestingly, this guy ended up getting his PhD, and then I guess like all good Germans who knew how CO2 worked in water, he went to work for a brewery. So it worked out well for him. There is a thermodynamic model for H2O and SiO2 that just came out. So this was kind of lucky that just came out. So that thermodynamic model can look at the solubility of H2O and SiO2 at high temperatures. So what we want to know is can AI produce a strategy and code to build an equation of state with this limited data? And because we want to do it for the whole system, and then can AI help define key future experiments to validate the model? So it's one thing to build a model that would predict data, but then pretty sure not going to fund that because you don't have any way of validating them. So we need now to come and say, what's the future experiments we need to validate the model? Hopefully we get a graduate student who's willing to spend the next 2 years of their life in the lab collecting that data. Okay, so first thing I had to do was, this is that PhD dissertation that I mentioned. You'll notice it's in German. You'll also notice that it looks like it was printed out in 1980 on a dot matrix printer. And this is the only copy we have. See this black over here? That's because we had to scan it in from a paper copy that we had. And whoever was scanning it that day was not super careful. And so everything was crooked and distorted. And if you look at these tables, they're a complete nightmare. So you've got phase boundary data along with molar volumes, and it's all mashed into one table. But luckily, this is one of the places where AI can shine. So we use the vision capabilities within Claude. And I said, convert these, I use the German word, tables in Garrick to CSV, comma separated values, combining the phase boundary and molar volumes converted to English. And it did a pretty darn good job of it, but I had to do an iteration loop where there was a couple of the tables that just could not figure out because they were just, the layout was just nightmarish for something to detect. But eventually we got to about 99% accuracy. something that would have taken probably 40 hours because there was 5,000 data points, we were able to do in essentially in minutes with AI. So that's using it as a tool, not all that exciting. But here is the SiO2H2O thermodynamic model. And what I did was I stuck that model in the folder as a PDF. And I said, using that paper, create a Python script to generate a synthetic data set for SiO2 and H2O at similar T&P as Garrick 1980. So here's the data set I built just previously. And there's the paper. And in the paper is the thermodynamic model. So it goes through the paper and it reads the model and then it generates the code. Now, Bob said, we should probably reach out to the authors and see if they have a version of the code and make sure that we're getting the exact same results. So the author was very generous to send the code, and they were the same. We did get the same answers. It was able to reproduce the answers exactly without any modification. And I might say that the AI code was slightly better. It was slightly cleaner and a lot better documented. Let's put it that way. Okay, so this is an example of the code that was generated. So it generated this SiO2H2O model.py. And here you can see just a small piece of it. And here's the gas constant. Here's some of the parameters from the model. It says where it got the parameters from. It comments on every number and tells you what it is. And then using that, oh, the other thing I want to mention is back one step. Do you notice that I said using a similar T&P that's in Garrick? So what it did was in the Python code, the first thing it did was go look at this file and figure out what the P and T range were, and then wrote the script to work within that T and P range. So I just want to call that out. That again, when you do agentic AI, it has the ability to grab context from other files. Okay, so generate that code, generate the same data set for this in the same format as the Garrick, except for now mole fraction SiO2 and H2O. So now I have all my data. I don't have any data that has all 4 species, but I have 3 species in one data set and 2 species in the other. So now I'm going to talk about using it as an ideation partner. And as an ideation partner, I went to Claude and I said, okay, turn on extended thinking, and I want you to do deep research. So deep research is a function where it will go out on the internet and it will search like 500 different websites, pull all the information together and synthesize it. And this is really useful when you have something that you want the latest and greatest. And we did want the latest and greatest because in this research, we're dealing with something that we're not sure if anybody's ever done any research on sodium chloride, CO2, and SiO2. But I said, investigate the most accurate equations of state for high temperature, high pressures for that mixture. The model should be able to predict densities and phase boundaries at subduction zone PT conditions. Rank the equations by state by accuracy, and then implementation effort in a table. And the top model that came out with was called EPC-SAFT. And EPC-SAFT is a thermodynamic model. It works using the Helmholtz free energy. I won't go through all the how that works, but it's a relatively new model that's gained a lot of popularity in the 2000s. And here's the thing, that wasn't really on Dr. Klaudner's radar as a potential model. So it literally suggested something that was not on his radar. And not only that, it said what ranges it was possible for, how difficult it was to implement. By the way, this is medium. Let me tell you, it was not medium. The reason that it's medium is because way down here somewhere are like quantum mechanical ways of doing it that would have required a supercomputer, the last like 3 of them. So it's not medium. And then here's the thing, it gave me a software package that will actually be able to do the PC-SAFT calculations. So this was something I was not aware of, that this software package existed. And it told me what model to use. Now, it also mentioned some other models that Dr. Wagner was super familiar with. And he said, yeah, you could use the DO model, but it's not great because of this reason or that reason. The DO-ON model, you could use that, but it's not great because these reasons. He said, let's try this EPC SAP model. So I went and found that code that was telling me about, that the large language model was talking about, this PC SAP package. And I downloaded it and installed it. It turns out to be a Python package, but it also had C++ code in it if you wanted to torture yourself. And it had documentation. So it had the read docs documentation. It has all the functions that are available, and it even has example code. Okay, so now I think I have all the pieces of the puzzle. Oh wait, almost all the pieces. I do have the data. I have a thermodynamic model for SiO2. I now have a way of building an EPC SAP model. The last thing that I did, oh wait, did I do, sorry. Oh yeah, I did. Okay, and then I have the deep research. So I do have all the pieces. So I also have my deep research. Now that deep research, I'm showing one page of it here, but it was actually a 40-page summary of everything. It was like a full literature review on what had been done in this space. And then it had like a lot of coverage about why SAP would work, why DO would work, what some of the limitations were. So it was a very comprehensive document. So when I get to this space, I now have the data, thermodynamic model, the software I need, and I have the deep research, which gives me 40 pages of context about how to solve this problem. So how long would it have taken me? How long did it take me to get to this point when we first were doing this? We did this like 9 months ago. We didn't have Claude Code. It took us probably about 2 months to get to this point. With Claude Code, I can do this in an afternoon now. Okay. Now, you know, obviously I know more of what I'm doing, but the mechanics of pulling this together is now an afternoon, not 2 months. Okay. So now within Claude Code, there is this function called a init, and init says, go read all the contents of this folder and summarize it into a file that summarizes what's in the folder, because now I'm getting ready to do some big agentic work. So I ran init, and it went through and made a big summary of everything that was in that document, in that folder. Now I'm ready to rock. Okay, so now I'm ready to do ideation, build my model, test my model. And so I'm going to do this cycle here where I have Claude generate code and other outputs. I'm going to fit a model to my experimental data. I'm going to generate plots that look at how well my model works. Okay. And then I'm going to interact with the model to refine my approach. So I'm going to do a cycle. I'm going to see what it says about the cycle. And then I'm going to also give input, and then we're going to do another cycle, and we're going to do another cycle, and another cycle, until we get the results that we're looking for. Down here at the bottom, you see it says vision model. So when the code generates the plot, the fit, you know, where you kind of calculate how well your model fits, it uses the vision model then to look at those plots so that it understands how well the model fit. So it literally generated the code, ran the code, generated the output plot, opened up the output plot image, looked at the output plot, said, oh, you've got significant misfit here or there. Here's what I would recommend. Then we got to this point, and I said, okay, I don't want that, I want this approach. Generate another thing, and we do a cycle. So you can do about 30 to 40, this entire process for fitting our model ended up being like 30 to 40 cycles of refinement. That we can do probably in about 2 to 3 weeks. So you can set up the experiment, gather all the data in an afternoon, and then you can go through this whole model refinement process. It might take 2 to 3 weeks, but during that, we do 30 to 40 refinement cycles. Now, how long would it take me to do one of these refinement cycles? A lot longer. To do 30 or 40 cycles would take me months to do that. So it essentially is a great productivity enhancer. So here's me now running the initial one. I'm saying, here's my data, build the EPC SAP model. I don't even tell it to use the PC SAP software, it just knows. And then create my validation outputs, and then I always ask it to ask clarifying questions. So here it's looking to see if PC SAP package is installed. It's doing some tests to see if it can run code. Oh, here it's reading the CSV file. I'm trying to remember. Oh yeah, it does. Just give it one more second. Okay, so it comes up with its questions. And it says, what are you trying to predict? Molar volume, density, SiO2 solubility, all the above. And I'm mostly interested in molar volume and density at this point. And then it asks the very different conditions. Oh, I didn't even realize that. Oh yeah, because it doesn't go as low. Okay. Do you want to create a model of all of them or some of them? I wanted all of them. Then it's asking me about the PC SAP parameters for the pure components, because I don't have that data. And so I say use it from the literature, and so it's going to do a web search to find those values. Okay, so I won't make you sit through while it's running, but essentially it ran for about, I think it ran for about 30 minutes. And what I ended up with was a first round fully parameterized EPC SAP model. And I won't go through all these parameters are, but essentially it goes through an optimization process to figure out which of these parameters make the data fit the model the best. And the pure component values that are here, it got via web search. And the interaction parameters, the parameters down here, it got by fitting the experimental data. And here's an example of the fit for the Gehrig data, which is NaCl CO2 H2O. The mean absolute error was less than 5%. So it did an incredibly good job of fitting the data across the whole PT range. I wish I could have just stopped there and been like, okay, it's ready to publish. Except it gets more complicated when you get to SiO2. So if you know anything about SiO2 or SiO4, it forms a tetrahedra, and they love to snap to each other. And it formed things like glass and quartz, and like it likes to bond to itself. And so if I get to a whole fraction here of 50% SiO2, you're no longer talking about a liquid. You're now talking about a glass, okay? And the rules sort of change in a glass versus a liquid. And so what was happening was it was fitting well in the liquid phases, but once it started to get up into the glass phases, it really kind of fell apart. So here's where the model comes in. It saves the day. I didn't even tell it to do this. It was looking at the outputs. It looked at that SiO2 and it said, oh, you have significant misfit in high fraction SiO2. So it postulated the lack of fit was due to self-association, polymerization effects. And then it recommended we model the polymerization in the SAP model as a 4C association scheme. So essentially it's like this equilibrium system of different species of SiO2. And then it creates parameters for each of these species, so that it's not just got one parameter for SiO2. It now is including all of these species that are in equilibrium.
Scott, where did it learn this chemistry?
From the training it had.
From just that one paper on SiO2?
No, from the training that Anthropic did.
From the deep research step?
No, from the training that Anthropic did. So it knows EPC SAP, it knows all of that already.
Yeah, you did not have to train it.
I did not. No.
Interesting.
No. The only purpose of the deep research was to make sure that if there was something that was in the last 6 months where the model wouldn't know about it, to make sure it was in there. It was not to teach it
Mhm.
chemistry. It knows chemistry already.
Mhm.
Yeah, it's crazy. So now we can better model this, where you've got the silica tetrahedra connecting to each other, and these different species that are compounded with water and hydroxyl groups. And doing that, then the next we took a couple of iterations. Oh wait, let me back up. Whoops, wrong way. It actually started with a simpler scheme, the not 4C, that had less species, and it didn't really improve things much. And it said, okay, I tried that, but it doesn't look like it improved the fit much. It said, well, we could go to a more complicated 4C scheme. And that was after a couple of iterations. I don't want to make it look like it solved everything right off the bat, okay? So this is what we were going from like 20% error down to 2 to 8% error, depending where you were in PT space. So at really high temperatures, it still had about 8% error, but we were down around 2% for most of it. So using that self-association scheme made a massive difference. Okay, so that's that use case. I just want to throw out a couple of things, my sort of call to action. First of all, I want to mention that there's an AI research course that we're running. It's been run already for life sciences and for geology, but there will be more of them coming up if you didn't make that one. And there's a website you can go to here that has all the materials that we teach in that class. We cover a lot of this material and a lot of other simpler material. There's also AI research work. We meet every other Thursday. And it's kind of picked up. It's kind of taken a life of its own, where we're doing a mixture of things, where people are talking about the research. There's some like educational pieces to it, and then now we're working on coming up with some ethical and application guidelines. If you want to join that, we'd love to have you join it. It's typically in Gilbert Place, but you can also do it online, and you can contact me or Jen Pike to join that. John comes occasionally too. There's a bunch of AI productivity apps that I want you to know about that are built in the Academy of Data Science. This is sort of bonus material. One is that I just built for the math department, is an AI handwritten note converter. You can upload your notes in PDF, handwritten, and it will convert them to LaTeX, Quarto, PDF, or Word, and it'll make them accessible. So it supports the 2.1 standard AA. And you can convert this was a big problem for the math department. There was a lot of notes that they had written, they wanted to share with their students, but starting next semester, we can't really do that unless it's accessible. So this converts them to something accessible. This is a curriculum generator that will build an entire course for you using AI, and you can specify what the topics are, but it'll recommend what the topics should be, and it will build the entire course for you with quizzes, exercises, and all that. And there's a bunch of tools there. So if you get bored and you want to go see that, those tools are all made available for free by the Academy of Data Science. And then here's my quick call to action about giving AI a try. So if you want to use Claude Code, these are instructions on how to set it up. And we have an API key that I said is funded. It's got a couple $100 still left on it, so it'll last for months if you want to try Claude Code. But there's also this Virginia Tech one now. And the Virginia, so if I have the, oh yeah, so I don't have it, but the Virginia Tech one, the instructions on setting it up are in here. It's 100% free and it's 100% safe. So if you have PII or IP information you don't want to share, but you want to try this agentic stuff, you can use that particular.
So it is same as the Claude Code.
What's that?
So this Virginia Tech key is also same as Claude Code.
It's not the same. It's using the Gemini CLI code. So it works like Claude Code, but it's not exactly the same.
But it can do the same.
Yes, same thing. Yeah. Yeah. And the exciting news that we got yesterday, after I guess we nagged him enough, they just released the Kimi 2 model on ARC. And the Kimi 2 model is open source. It only runs here at Virginia Tech. It's supposedly as good as Claude, as good as Google, and as good as OpenAI. I've been testing it and been getting really good results, but it's really kind of the best possible scenario. It's VT, it's safe, and it's a really good performance. And we're going to continue to test it. Robert Weiss and I from Geosciences are doing a kind of working through all and see if we can find any issues, but I think it's ready to go and ready for you to try. And so with that, I'll just leave a couple minutes for questions. Yeah.
Any other class, as you said that you're also teaching AI research class for life sciences, do you have it next semester?
Yes, so we will have it. We haven't scheduled the other, but all the departments within the College of Science are going to run the class, and so you can come to any of them. So there will be one for physics and chemistry and different, and so you can come join them when they're announced. But we haven't scheduled them yet.
So is it possible, like, are you planning to do it next semester?
Yes, yes. The plan was to do them all this semester and next semester, but because of scheduling, I don't know if that'll happen. But there will definitely be some next semester.
Campus will open to grad students.
I'm sorry.
They've been open to graduate students, are you a graduate student? Not widely advertised
Yeah,
yet?
Yeah.
I
I think they need to.
you're welcome,
they're gonna catch.
for sure, welcome to attend.
Yeah.
We really want faculty to attend,
Yeah.
so that faculty know what
What-
graduate students and postdocs will be using the tools for, and what the outputs are, and where some of the
Mhm.
problematic areas are, because it's ultimately faculty who's
Mhm.
the last name on publications, so we're responsible for what comes out of the group. Faculty have got to know this pretty well,
No,
but it's you who's going to be using it 100%, so you can definitely come.
I was thinking that maybe in that class, if they are teaching like this stuff, or it could be more like faculty focused stuff.
No, it'll be this.
Okay.
Yes, it'll
It's
be
really
this.
good.
Yeah. I also want to throw a plug out there. Next fall, I'll be teaching an Agentic AI class in the Academy of Data Science for graduate students. It's a graduate level course. I don't know if we're going to allow undergrads, but it'll definitely be for graduate
That's a
students.
good route, yeah.
Any other questions?
And how we can get that APN key you mentioned for Claude Code, like maybe in
Yes, yeah, I can send send it out. What's the best way for? I guess I could just do an email reply with the code for Claude for them to be able to test it out. That's probably the best.
For
The API key so they can
No.
test Claude code.
no, I know, but who do we want to send it to? Like, just,
I mean, it's supposed to be for anybody to use, so.
you know, I mean, for now, email Scott
Okay.
Yeah.
on an individual basis, but
Yeah.
we'll,
Okay.
well,
All right. Yeah, I don't want to overstep, but
yeah.
yeah.
I just don't want to increase email traffic unnecessarily right now.
Okay.
Or-
Oh, yeah, because, yeah, agreed. Yeah, Joni, you had a question?
Yeah, can you explain a little bit how you did the iteration with the AI? You said you like 30 to 40 cycles. Are you saying like you would have it like go through the whole process and then you'd look at its output and then say more, like try again, or is this automatic?
No, there was a human in the loop. There was me in the loop. And so what I would do is I would say, make the changes that we talked about, look at the outputs, make suggestions on further refinement, and then it would stop. And then I would go look at the code that was generated. I would look at the outputs. I would look at everything. And then I would look at its recommendations. And then together we would decide what the next step was. And then I would say, okay, now do this. So that it was not, yeah. Agentic AI is not 100% automated. It's
Yeah.
semi-autonomous, but that's the level I was using it.
Yeah, Ronan and I have used Cursor in the past.
Yeah.
And we'll just have it like iterate on itself until
Yeah.
and change like test cases
Yeah.
until it reaches a certain threshold.
Yeah. Yeah, so that's one thing I didn't mention is test cases. So if you know the answers to something, you can actually have it iterate on it and use the test case to test it and don't stop until it
Yeah.
passes all of
yeah.
the test cases. Yeah, in this particular circumstance, there was no perfect answer.
Mhm.
So it was refining, getting better and better. It wouldn't have known, I guess I could have set a threshold and said, when you get within this mean absolute error, stop. But yeah, but you could theoretically just let it sit there and run in a loop.
Scott, can you think out a little bit, 3-5 years from now? There are a lot of people in this field who think, artificial general intelligence will be here for the next few years. What does that do for science? And how do you think we'll be using AI in 3 to 5 years?
Yeah, so how they define AGI is different, but like the layman's way of defining it is that you define an AI that's smarter on every topic than every human on Earth. Okay. Well, I would already say that they're pretty close to like they're pretty smart on just about every topic, you know. So in some topics they're like PhD level, some they're not quite to that level, some they're even like in coding, they won the gold medal competition this year. And then in some of the science competitions, they've won the gold medal competitions against humans. So I think we're getting closer. There's a question of whether we'll actually reach it, because some people think that until the models have a world model, they can't actually get to that point. So a world model would mean they understand how things should behave. So right now, all it's doing is generating the next token, and it's creating the most plausible next thing, right? But it doesn't understand how things are supposed to behave. So if it comes out with an output that is obvious to us as humans because we know how things behave, it doesn't have that ability. So all of the major AI companies right now are working on LLMs that have a world model, and it's way more complicated. But essentially, like they would have a chemistry world model, so that it would know principles of chemistry and what to expect for outcomes, and then it's not just predicting next word; it's using that model. I think that's going to have to happen before we reach AGI. And then the question is, can they ever get to the point where they come up with a completely 100% novel new idea? And some people have argued that they can, and there's been a couple of examples where people have done it in math. They've solved things in a way that people would have never thought of at this point. So it's really debatable whether or not you can get to that. And I think until we answer those questions about can we get to AGI, can it do true innovation, I feel safe. Like, because I still feel like it's got some limitations that are going to keep it from ever taking over what humans can do. But they are incredible automation tools.
Yeah.
You know? Yeah, I know that's a really hard question, right?
No, I know. I just wanted you to
Yeah.
confused about that a little bit.
I've done a lot of thinking about that, and I don't know what the answer is.
Yeah.
But if you'd asked me, would we be here a year ago, I'd be like, there's no way.
Okay.
If you'd asked me 2 years ago, would we be here? I'd say you are completely nuts. Right? Because we were essentially in a desert. Like there had been no real advances in AI in 50 years since the multi-layer perceptron, you know? And then one scientist came up with the idea of creating this attention mechanism where now when you input the information, it has the relationships between the words, and it changed everything. So it's like, it's just hard to predict what the next big breakthrough is going to be.
Sure.
Yeah.
Thanks.
Yeah.
So sort of related to that, the reason you can do all of these things is that you actually do code, right? Like, so you're getting the agent to work with all these other interfaces, because if you just work within the thing itself, it might give you an answer, but it won't give you the process.
Right. So there's still a human validation that has to happen, and because for agentic AI, you really want it to generate code so that it can do that cycle. You do have to be able to validate the code. Now, there's human validation, which is the best, but you can also validate it with other large language models, and they can often find issues. But ultimately, it's hard to say, I created this publication on something that I'm not even 100% sure what the code does, right? So there is sort of that final mile that is going to require human validation.
But even thinking about like industry, you know, like you said, like 5 years ago, I would have said my kid should definitely become a computer scientist. And now it's like, whatever you do, don't become a computer scientist.
Yeah.
But then everything that I've just seen you show us, it's like, no, maybe you should become a computer scientist.
Well, so the other thing you have to realize is that we're at the cutting edge of all of this. So right now the tools are what I would consider to be like only for the people that love new technology, and they're not for broad adoption. That's going to change.
Okay.
That's all 100% going to change. It's already starting to change. And these tools will be baked into everything, and there will be a lot more accessible. And I think that is, I would not suggest to someone that they become a coder at this point. I would not.
Yeah, because what you said, it still takes a human to validate the code. That's not going to be the case in 6 months.
Yeah.
I'm guessing.
That seems,
Yeah, I think
I agree.
that'll be solved.
so like basically there will be an automatic car version of this where I don't have to learn stick shift.
Yeah.
I love driving stick shift,
Yeah.
but
Yeah, and this is pretty close to that, if you accept that the code's right, that's your major issue, right? So, and you could take that code and throw it at 5 other large language models, and if they all go, yep, this is sound code, there's probably a pretty good chance it's sound code, but you never really know.
And the scientists, we have intuition on what the output should be.
Yeah,
If they match our intuition, then maybe it's pretty good.
yeah, there was a couple times that Dr. Bodner set me straight. He's like, okay, generate this makes no sense. And I was like, oh, okay, because I didn't know. Like for one, I didn't take solubility into account. So at some point, silica stops being soluble in water, and that changes everything.
Yeah.
So you can't, this doesn't really work when you end up creating a glass. There needs to still be solubility. And so you have to be at the temperature and pressure and SiO2, where SiO2 is still dissolved as a species. It's still polymerizing, but it's not a glass.
Yeah.
And so I didn't know that because, this is a little beyond my understanding. And he's like, oh, yeah, it doesn't make any sense. And I said, oh, so then I had to go back and add in a solubility check to make sure that it was soluble.
So if you did that project today with Cloud Code, you said you could do it a lot more efficiently, but would it also give you a different result? Would you think you would generate a more accurate?
I did redo it. Essentially gave me the same thing. Yeah, because the EPCC SAP model is the EPC. It's like it's not. I don't know how it would generate a better result. Yeah. Other than maybe some new model or some data preparation technique, but it didn't. It just went through the same path that it went before. Wait, there was another question.
I just wanted to ask, like you showed the example where it was doing all the machine learning models, which ML person does, so it can completely replace somebody.
Oh, that hurts that you're asking that question. Yeah, unfortunately, a lot of that level. But here's the thing that people don't know about data science is the real data science is not in picking the model, running the model, and evaluating the model. It's determining what goes into the model. So the features that you put into the model often require you to understand the domain you're in and then the data and combine them to generate features that have predictive power. You can't just take the world's best algorithm and throw raw data into it and expect to get good results. So the data scientist is now shifted more towards away from modeling, because everybody's version of gradient boosted trees is exactly the same, but figuring out what data goes into it is where data scientists now are valuable.
So
That's what I tell myself anyway, because I'm a data scientist.
If I can also do the machine learning with the help of Cloud Code, I don't need collaboration with machine learning. Like I know my domain knowledge, but I can go with the help of.
I would be careful about that because,
Like I have taken some of the machine learning, but I am not I haven't taken computer science type of learning, but I have taken machine learning and statistic courses in my department.
Yeah.
Like with this help, I can do it by myself. I don't need.
You can, but again, I would just be careful to make sure that you at least validate your final code and process, and don't just assume that it's right.
Yeah.
Because that is one thing that scares the heck out of me, is that it's so easy to use this as a crutch. And just have it do everything for you and never validate it. That scares me so much, because we're already seeing it now with students that they depend so much on using chatbots to do things for them, and that it's going to impact critical thinking and a lot of hard work. So I have mixed feelings.
I think for folks who want, there should be some sandwiches across the hall if you want to ask more questions, but thanks so much, Scott.